Oh, thank you for asking. Um, and Deborah, what have you done today?
Today I go to the gym. Actually,
Went.
I'm on my vacations. I went to the gym. I'm sorry.
No
I'm
worries.
on my vacations, so I'm not working.
Okay, I'm on vacation.
I'm on vacations.
Yeah,
On vacation,
just
not plural. I'm
vacation.
sorry.
Yeah.
Got it. I'm on
Okay.
vacation, so I went to the gym and studied a little.
Okay. Nice. Sounds like a pretty good day. Deborah, do you have headphones? It might help a lot because there's an echo when I talk, so I can hear my voice from your computer. If you have headphones, any sort of headphones, it'll just kick out the echo, which is
Oh,
really helpful.
I will do it right now. Just a minute.
Okay. Um, and Michael, are you to Australia for? Is it your job?
Well, actually, I am in the resident permanent visa process.
I
Okay.
did it.
So,
I can just go. Tell better.
Okay, perfect. And yeah, so hold on, Deborah, one sec. And can you explain again, Michael?
I'm not listening, Joshua.
hello.
Hey,
Sorry, I had a
so
problem
you're
with
in
it.
the,
I didn't hear your last
no
question.
worries. So you're in the permanent visa process?
Yes. So in the beginning, we are going, my wife and I, we are going as a student, just
Okay.
because I need to take an IELTS test, and
Uh-huh.
I have taken 5 tests, and I didn't get the grade just in writing. All the grades I have, uh, all the skills I got the needed grade, not just in writing. So I need to practice a little more. So
Okay. So
we are going as a student in the beginning, and I'm going to continue the resident permanent visa process up there.
nice. Okay. Good. That'll be awesome, and hopefully it works out well.
Yeah,
So you got the grades and everything except for writing. So you need to improve your writing scores. But yeah, good luck
yes.
for sure.
Thank
And
you.
Heidi, welcome to class. Heidi, how's it going?
Hello, nice to see you again.
Nice to see you too. Good morning.
Good morning. Baby is very close to me, but now very quiet. She's in a
Nice.
good mood now.
That's good. Babies in good moods are the best kinds of
Yeah,
babies.
she slept well and she woke up a little before. Then she got some breast milk. She's very good.
Good. Nice. And so what are you gonna do today?
hmm Every day we need to go out because when we go out with the baby, she's very good and she's very glad going out like a
Nice.
dog.
So when you go out with the baby, she's really glad. So she likes getting out of the house and doing something.
Very
I think
similar to
he'll.
dog.
Yeah. Okay. Cool. Um, and Amp, how's it going?
Hi, teacher. Doing well, thank you. What about you?
Good. I'm doing really well. Thank you for asking. Looking forward to today's comics or reading. It's funny. Um, and Amp, what'd you do today?
Today was a sunny day. I have to water my plants, and yes, most of the time I've been inside home because it's really, really sunny. It
Okay.
was really sunny. Mhm.
Cool. Nice. And yeah, I guess sounds good. Was it really hot as well as sunny?
Yes.
Yeah. Okay. And Rafaela, welcome to class. Rafaela, how's it going?
Thank you. I'm fine, and you?
I'm doing really well. Thank you for asking. Rafa,
Sorry, my connection isn't good.
Wasn't a enter class, it freezes a little bit. Um, Rafaela, where are you from?
I'm from Brazil.
Okay, I was gonna guess that with a hat. And
I'm
Rafaela, what do you like? What do you like to do for fun?
I really like to go to the movies.
Nice. Okay. Do you have a favorite genre of movie?
I like fantasy
Okay.
and
Do,
fiction.
do you have any favorites?
What?
Any favorite fantasy movies?
Fancy?
You like fantasy movie?
Ah, fantasy movie. I really like Lord of Rings.
Nice. Yeah, I would like The Lord of the Rings as well.
Mm.
Okay, I'm good. It's good to meet you. Herman, how's it going?
Hey Joshua, I'm good. Why are you so dark?
It's dark here. I can't get any lighter than this. This is as light as it gets. Yeah. But yeah, so Herman, what'd you do today since I saw you last?
Since last class, I play PlayStation,
Nice. What game?
Medal of Honor on
Okay.
internet, killing other
Nice.
people.
I I used to play that in college. My friends used to like it, and so every once in a while I'd play, and it was like consistently dying. I just die consistently. It's terrible.
Yeah,
Um,
it's hard.
yeah, people are really good at those games. All right, and Fidel, welcome to class. Fidel, how's it going?
Thank you. Everything is okay.
Okay, nice, good to hear. And Fidel, what'd you do today?
Nothing. I mean, I was um, in a meeting with the in the school, my son's school.
Okay.
So the teacher told me that I need to help him more.
Hmm, that's tough. Okay, what grade is your son in?
Excuse me?
What grade is your son in?
Oh, he's in the first grade.
Okay,
He's
nice.
7 years old.
This is pretty young. Okay,
Yes.
cool. All right, well, hopefully it works out. Shinwei, welcome to class. Shinwei, how's it going?
Hi, teacher.
Hey, how are
The
you?
day I'm fine. The day before yesterday, I had the interviewment. If I passed that interview, I would get a teaching certification.
Nice. So you passed a job interview?
Uh, if I got that teaching certification, I would teach English in China like you.
Nice. So that's what you are going to do? You're going to be teaching English?
Currently, I am teaching history in China.
Mm-hmm.
If I got that certification, I would teach English in the future.
Okay. So if you get the certification, you will be teaching English?
Yes, yes. If I get
Nice.
that, I will teach English like you.
Nice. Okay, yeah, so we'd use the present tense. If I get, I will. Um,
Uh,
okay.
yes,
Yeah,
yes. But in that interview, I made a lot of mistakes. I
okay.
was so nervous. Uh, for today, I am very, I am very curious.
Okay.
Mm.
Okay. Maybe we could use the third conditional in this case. If I had passed the interview, I would be teaching English.
Mm. Mm. Mm.
Uh,
Mm. Yes, yes.
okay. Okay.
Oh,
Yeah.
oh, teacher, I find a big challenge when
What's the
I
challenge?
mm, uh, when I when I am writing English, mm, my mistakes would be less. But when I am speaking English, I like to make some mistakes. My writing English is better than speaking English.
Common. A lot of
Mm,
people, because you have a little bit more time to think, you don't have to kind of go on the cuff.
mm,
You make less errors. You make fewer errors. Um,
mm.
but
Uh,
yeah, it's one of those
I
things of practice.
yes, yes. I often make some easy mistakes. When I finish my talk, then I realize my mistake.
Yeah. Yeah. It's okay. It happens to everybody.
Eh,
But yeah, practice makes perfect. So that's the best way to get better.
mm,
All right. Let's start with Misael. Can you read the question?
mm.
Sure. What would happen if you try to hit a baseball pitched at 90% the speed of light?
Good. Does anybody have any ideas before we get into this? Any ideas as what would happen?
Maybe the ball would travel in the time.
Maybe the ball would travel in time. I like the answer. Travel in time. Okay. Good. Any other ideas?
No one can hit.
Can hit it. Yeah, so no one can. Maybe no one would be able to hit it. Yeah, for sure. Any other ideas?
Probably if you could hit it, the bat would explode with the speed and the power of the ball.
Yeah. Okay. Good. This is gonna be fun. Let's look and read this first part. Heidi, can you read the first paragraph?
Okay. Let's set aside the question of how we got the baseball moving that fast. We'll suppose it's a normal pitch, except in the instant the pitcher releases the ball, it magically accelerate to 0.9 what c? I don't know c.
It's the speed of light.
From that point onward, everything proceeds according to normal physics.
Good. Releases
Releases.
magically. Magically.
Magically, not magically.
Not magically.
Mm,
Magically.
magically.
Magically. One more time.
Magically.
Perfect. There you go. Accelerates.
Accelerate.
Yeah. Accelerates. Did I? Are you still there?
Yeah. Accelerate.
Oh. Yeah. Okay. Accelerates to 0.9 c. But okay, good. And
I'm sorry. Accelerate to 0.9 c.
good. There you go. And this is a little graphic before it's going 80 miles an hour when it's still touching his hand. Then after it's going 604 million miles an hour. And Herman, can you read the next paragraph?
Okay. The answer turns out to be a lot of things, and they all happen very quickly, and it doesn't end well for the bed batter or the pitcher. I sat down with some physics books, a Nolan Ryan action figure, and a bunch of videotapes of nuclear tests and tried to sort it all out. That follows is my best guess at a nanosecond by nanosecond per thread.
Nice. Action figure.
Where is it?
Action figure.
Action figure.
It's got like a gear. Figure.
Figure.
Good. Nice. And other than that, you did a great job. Amp, this is the question. By the way, I know you just came back. And, all right. Any questions here in these first two parts? Any questions? Okay. Let's have Fidel. Can you read the next part?
Okay. The ball is going so fast that everything else is practically stationary. Even the molecules in the air are stationary. Air molecules vibrate back off and forth at a few hundred miles per hour, but the ball is moving through them at 600 million miles per hour. This means that as far as the ball is concerned, they are just hanging there frozen. Hanging there
Yeah,
frozen.
okay. And I missed what you said at the beginning. Can you repeat the first two sentences?
Okay. The ball is going so fast that everything else is practically stationary. Even the molecules in the air are stationary.
Nice, okay. Let's look at practically. Practically.
Practically. Practically.
Good.
Practically.
Molecules.
Molecules.
Yeah, molecules.
Molecules.
Perfect. Any questions here?
No.
Okay.
No.
All right. And Deborah, can you read the next paragraph?
The ideas of aerodynamics don't apply here. Normally, air would flow around anything moving through it. But the air molecules in front of this ball don't have time to be jostled out of the way. The ball smacks into them so hard that the atoms in the air molecules actually fuse with the atoms in the ball's surface. Each collision releases a burst of gamma rays and scattered particles.
Nice. Okay. Good reading. Let's look at aerodynamics. Aerodynamics.
Aerodynamics.
Nice. Aerodynamics. Molecules.
Molecules.
Jostled.
Jostled.
Yeah, jostled.
Jostled.
And scattered.
Scattered.
Scattered. Good. Questions here. Does anybody have any questions about any of these words or anything that's happening here? All right. Deborah, can you go over what's happened so far? What's happened so far? in what we've read? Deborah?
Okay. And try to figure it out. I don't know.
Okay, who can explain what we've read so far? Can anybody paraphrase what we've read so far?
Can I talk?
Yeah.
Yes.
Uh, mm, uh, th- this paragraph talks about uh, the the talk talk about this ball is blowing into the air, but mm, because the speed of the ball, mm, the traditional aerodynamics ideas doesn't work in this situation.
Okay. Yeah, but because of the speed of the ball, traditional aerodynamics, like traditional ideas about aerodynamics, don't really work. Yeah. So the ball is actually fusing with the atoms in the air. So there's fusion, nuclear fusion going along right now. Perfect. And
Yeah, and
sorry.
probably the ball is going to get bigger because they are fusing with the air atoms.
It'll change for sure.
When some objects move in the air, there are a lot of molecules in the air. Then they cut and divide that molecules, and then they go advance. But this ball is very fast, so the molecules that don't have any time to refuse the ball. So the molecules hit the ball, and then it crashed. Kind of nuclear fusion happened. So they
Yeah.
release a lot of I'd say substances or radioactive substances.
For sure. Good. Nicely done. And so this is kind of a demonstration or an explanation of what is happening. Amp, can you read this next paragraph?
Um, Let me refresh it. Okay. These gamma rays and debris expand outward in a bubble centered on the picture's mound. They start to tear apart the molecules in the air, whipping the electrons from the nuclei and turning the air in the stadium into an expanding bubble of incandescent plasma. The wall of this bubble approaches the water at about the speed of light, only slightly ahead of the ball itself.
Good. Okay. Incandescent.
Incandescent.
Nice. Incandescent. Nuclei.
Nuclei.
Yeah, nuclei. And what was the other one? Tear.
Tear. Yeah.
Yeah. Tear apart the molecules in the air. Good.
Tear apart.
Okay. So some pretty awful things. Does anybody have any questions about the words here? Any questions about words?
What's mound?
The pitcher's mound. It's like the hill. Mound is a small hill. So
Okay.
in baseball, we have a pitcher's mound, which is where the pitcher would stand.
Okay. Thank
Yeah. And I don't know if we can see this. Can anybody? Oh, sorry. Hold on. Yeah. Let's read this comic. Shinwei, can you read the comic? Can you see that?
Comic.
This one.
Uh, Oh, uh, I'm not sure the capital letter.
Ah, right. Okay. Maybe Rafaela, can you read this comic?
Um,
Or is it
time
too
is
small?
equal time is equal 30 nanoseconds. There is
Good.
an unsuspecting batter. He's not suspecting the
Yeah, anything.
what he will receive. There's play play. How can I say that? Play mais de ar.
Yeah. Air.
Play mais de ar. With an X-ray front.
There's the
The fireball is developing, and the there is a disintegrating picture.
Good.
Poor
So also
picture.
poor pitcher, poor batter, poor everybody.
Yeah.
Right. Shinwei, can you read this next paragraph?
The
Sorry.
constant the constant fusion at the front of the ball pushed back on it, slowing it down, as if the ball were a rocket flying tail first while firing its engine. Unfortunately, the ball is going so fast that even the tremendous force from this ongoing ther- thermonuclear explosion barely slows it down at all. It does, however, start to eat away at the surface, blasting tiny particulate fragments of the ball in all directions. The fragments are going so fast that when they hit air molecule, I don't know pronounce this word. Uh,
Molecules.
moleculars,
Molecules. Yeah,
molecule,
molecules.
oh,
Molecules.
oh, molecules. You right?
Mol. I. You're missing the I. But yeah, molecules.
Molecules,
Cules. Can you repeat cules?
cules.
Good. So
Oh,
mol,
mao,
I,
mao, eh,
I,
eh,
cules.
mm. Molecules.
Good. And can you read the rest of the sentence?
Um, the the tri- the trigger 2 or 3 more rounds of fusion.
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 Yeah, fusion. And tremendous.
Tremendous. Tremendous.
Unfortunately.
Unfortunately.
Thermonuclear.
Uh, can you repeat this word?
Thermonuclear.
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 Nuclear. Thermonuclear.
Oh,
Nuclear. Yeah.
thermonuclear. Thermonuclear. I,
Thermonuclear. Like that. Nuclear. Sorry, that was my fault. Thermonuclear.
Thermonuclear.
Good. There you go. Perfect. Barely slows it down. Barely slows it down.
Barely slows it down.
Nice. Barely slows it down.
Mm.
Perfect. Does anybody have any questions here? Okay. And Rafaela, can you read this next paragraph?
After about 70 nanoseconds, the ball arrives at home plate. The batter hasn't even seen the pitcher let go of the ball, since the light carrying that information arrives at about the same time the ball does. Collisions with the air have eaten the ball away almost completely, and it's now a bullet-shaped cloud of expanding plasma. Many carbon, oxygen, hydrogen, and nitrogen ramming into the air and triggering more fusion as it goes. The shell of X-rays hits the batter first, and a handful of nanoseconds later, the debris cloud hits.
Good. You did a really good job. Only a couple of small things.
Okay.
I saw plasma,
Plasma,
carbon,
carbon, sorry, carbon,
carbon,
carbon, carbon,
and debris.
debris. What's debris?
Does anybody know what debris is?
Small things like trash or something broken.
The
Yeah,
rest, the rest of something that was broken or destroyed,
for sure.
li- like an airplane when it crashed down, there is just the debris of it.
Good. Both of you, perfect. Does that make sense, Rafaela?
I shouldn't understand.
It's like the broken parts of something. So debris from a building that collapses or debris from an airplane that crashes. Small broken pieces
Okay,
of
okay.
something.
Thank you.
Yeah. Okay. Any other questions here? Okay. And Misael, can you read the next one?
When it reached the batter, the center of the cloud is still moving at an appreciable fraction of the speed of light. Sorry. It hits the bat first, but then the batter, plate, and catcher are all scooped up and carried backward through the backstop as they disintegrate. Just this. The shell of X-rays are superheated. Plasma expands outwards and upwards, swallowing the back scoop, both things, the stems, and the surrounding neighborhood, all in the first microsecond.
Nice.
It's a nice match. The
Yeah.
last one.
Good. And let's look at appreciable. Appreciable.
Appreciable.
Oh, yeah. Appreciable. And then
Appreciable.
outward.
Outward.
And then the backstop.
Backstop.
Good. Any questions here? Okay. What's an appreciable fraction of the speed of light? What's that mean, Misael?
Well, it's a really small fraction.
Not a really small fraction. Appreciable is like a sizable,
Yeah,
or
something
like
that you could appreciate. So probably
hmm
it's not too small. It's a good amount of it, a good amount of fraction. That
yeah,
could be.
It's still large enough to be noticed.
perfect. Yeah, it's like a relatively large fraction of the speed of light. Yeah, good job. Perfect, guys. And Heidi, can you read this next part?
Suppose you are watching from a hilltop outside the city. The first thing you see is the blinding light, far outshining the sun. This gradually fades over the course of the few seconds, and the glowing fireball rises into a new mushroom cloud. Then, with a great roar, the blast wave arrives, tearing up trees and shredding houses.
Nice. Good job with tearing up trees and shredding houses. Tough words. Um, yeah, that sounded good, Heidi. Any questions here? Yeah, it's pretty unbelievable. Um, and Herman, can you read the next part?
Everything within roughly a mile of the park is lit, and a firestorm engulfs the surrounding city. The baseball diamond is now a sizable crater centered a few hundred feet behind the former location of the backstop.
Good. Size. Let's start with leveled. Leveled
Leveled,
and sizable.
sizable.
Good. Perfect. And let's go. The next one, Fidel. Can you read the next part?
Okay. A careful reading of official Major League Baseball Rule 6.08b suggests that in this situation, the batter would be considered hit by pitch and will be eligible to advance to first base.
Yeah. Really nicely done. So considered. Considered.
Considered, considered,
Yeah.
considered,
Eligible.
eligible,
Eligible.
eligible,
Close. We emphasize the first syllable. Eligible.
eligible, eligible,
It sounds like you're saying illegible, which is unreadable. So we want to say eligible.
illegible, illegible, illegible,
Close.
illegible,
That's what you're saying. One is illegible, which is unreadable, and it sounds like illegible, like that. And the other one is eligible, which is again like eligible, considered legal to do something. That's a terrible explanation. It's like accepted, maybe. Eligible. One more time. Eligible.
eligible.
Okay. Yeah, it's a hard
Better?
one. Try to work. It's better. You're getting better. It is
Eligible.
emphasized on the first syllable. Maybe. Amp, can you repeat? Eligible?
Eligible.
Yeah. Can you try that one more time? Eligible? Fidel?
Me? Okay. Eligible. Eligible. No.
Almost.
The stress is in the
Almost.
first eligible.
Okay. Eligible.
Okay, you have an accent mark
There.
there.
Yeah. Yeah.
Eligible.
That was perfect. There. Nice.
Eligible.
Yeah.
Okay,
Kind
but
of.
talking about the reading, who wrote this story?
It's
You
a
found it in a
it's
book
a
or
comic.
something?
Actually, he does have
You
a
wrote
book.
it?
You can. No, 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 no. You can get it online. It's a comic called XKCD. And so he's a physics guy who does comics. Um,
Okay.
yeah, he is a professional webcomic. But yeah, the link is in the chat box if you want it. But yeah, that is not
Okay.
me. I wish I could write that. But no, I do not have the physics.
And draw.
Yeah, the drawings are pretty good too. But does anybody have any questions here? Okay, no questions. We don't have enough time to do the machine gun jetpack, so I think I'm going to try to do some short answers, and maybe we can save the machine gun jetpack for another one. So hold on, bear with me while we find it. Short answers, some second ones. Let's try this.
This guy needs to be so high to think about all these histories.
So the answers, I mean, are a little bit more reasonable. The questions are kind of crazy, but let's start with, I think we're at AMP. Can you read the first question?
If my printer could literally print out the money, would it have that big an effect on the world?
That big. Okay. Would it have that big an effect on the world?
Would it have that big an effect on the world?
Yeah, that big an effect.
Big an
That's
effect,
tricky. Yeah. And then literally.
literally.
Perfect. And also this. AMP.
Hmm? That that
Can
line.
you read? Yeah.
You can fit 4 bills on a 8.5 inches by 11 inch. Ah, X 11 or by 11?
By.
By 11 sheet of paper.
Yeah. In English, we'd say it's an 8.5 by 11-inch sheet of paper.
8.8,
So an 8.5 by
8.5.
11.
8.5 by 11 inches.
8.5 by 11-inch sheet of paper. Yeah.
8.5 by 11 inches.
Yeah, good. And let's have Shinwei. Can you read this next paragraph?
If your printer can manage one page, front and back, of full-color, high-quality printing per minute, that's $200 million a year.
Good. Can you repeat just the full color, high quality printing?
Full-color, high-quality printing.
Yeah, full color.
Full
So
color.
just peg them together. Full color, yeah. So when we've got them pegged together like that, it's a little bit quicker. So full color, high quality printing.
Full color, high quality printing.
Good. There you go. Perfect. And let's have Rafaela. Can you read the comic? excluding the last line?
Let's see, $400 per minute, and there are 525, sorry, 525,600 minutes in a year.
Yeah, good.
Them to hand rent.
Perfect. And Misael, can you read this last paragraph?
This is enough to make you very rich, but not enough to put any kind of dent in the world economy, since there are 7.8 billion $100 bills in circulation, and the lifetime of $100 bill is about 90 months. That means that are about a billion produced each year. Your extra 2 billion bills a year would barely be enough to notice.
2 million bills a year.
2 million bills a
Yeah.
year.
90 months.
90 months.
Yeah. And circulation.
Circulation.
More like circulation.
Circulation.
Perfect. Nicely done. Any questions here?
Teacher, I have a question. How do you pronounce
Yes.
this number? 7.8 billion.
Yeah, 7.8 billion.
Mm. Thank you.
Yeah, you're welcome. And let's skip that one. Nothing happens. Kind of boring too. This is kind of funny. All right, and Rafaela, can you read the question?
I bike to class sometimes. It's annoying biking in the winter time because it's so cold. How fast would I have to bike for my skin to warm up the way a spacecraft heats up during re-entry? I think so much.
Re-entry.
Re-entry, sorry.
Good. And then just the intonation. So how fast would I have to bike for my skin to warm up the way a spacecraft heats up during re-entry? So we emphasize how fast would I have to bike for my skin to warm up the way a spacecraft heats up during re-entry. So we we try to emphasize the most important words here. Can you repeat that sentence one more time?
Okay. How fast would I have to bike for my skin to warm up the way a spacecraft heats up during re-entry?
Good. And Heidi, can you read the first two paragraphs here?
Re-entering a spacecraft heat up because they are compressing the air in front of them, not as is commonly believed because of air friction. According to this calculator, to increase the temperature of the air layer, temperature of the air layer in front of your body by 20 degrees Celsius, enough to go from freezing to room temperature. You would need to be biking at 200 miles per second. Or second is okay.
Meters per second.
Meters, 200 meters per second.
Good. The only small thing? Calculator.
Calculator.
Nice. Perfect. And so that is pretty fast. Does anybody have any questions here? Okay. And Herman, can you read the next paragraph?
The fastest human-powered vehicles at sea levels are recumbent bicycles enclosed in streamlined aerodynamic shields. These vehicles have an upper speed limit near 40 meters per second. This is the speed at which the human can just barely produce enough thrust to balance the drag force from the air.
Nice. Okay, yeah, you did a really good job there. Um, you do a really nice job, Herman, of stringing the words together. So your like sentence intonation is really good. A couple things with the words fastest.
Sorry?
Can you, did you hear the first thing I said?
Yeah.
Okay. So the first word I saw was fastest. Fastest.
Fastest.
Yeah, fastest. And then
Fastest.
vehicles.
Vehicles.
Recumbent.
Recumbent.
Uh, shells.
Shells.
Good. Streamlined aerodynamic shells. Maybe streamlined aerodynamic shells.
Ah,
Herman?
okay. Streamlined aerodynamic. Oh, streamlined aerodynamic shells.
Good. I think you said it better the first time. That was good though. Nice correction. And Fidel, what about the next one?
Since draw increases with the square of the speed, this limit will be pretty hard to push any further. Backing at 200 meters per second will require at least 25 times the power output needed to go 40 meters by second.
Nice. Meters per second.
Meters per second.
Good. And drag.
Drag.
Yeah. So since drag increases with the square of the speed.
Since drag increases with the square of the speed.
Perfect. Nicely done. Good job stringing that together. And then amp. Can you read the next part?
At those speeds, you don't really have to worry about the heating from the air. A quick back of the envelope calculation suggests that if your body were doing that much work, your core temperature would reach fatal levels in a matter of seconds.
Yeah, your core temperature.
Your core temperature.
Uh-huh. A quick back of the envelope calculation. What's that mean? Amp? What's it?
A quick calculation.
Yeah, back of the envelope. Why is it back of the envelope?
The, the, the back of the envelope.
So, yeah.
A quick view, maybe.
Yeah, I mean, so it's pretty basic. You're right, it is just a quick calculation. A back of the envelope calculation is because you don't have any other paper around, so you don't even go through the amount of work required to get proper paper to do the math. You just use an envelope. You use whatever's close at hand. So it's like, some people, if they don't have like a notebook or a sheet of paper, they'll like write a grocery list on the back of an envelope.
Using what he has on him.
Yeah, exactly. And just easier and faster. And good. So, any questions here? Does anybody have any questions about this one? This is a good one to end on. I was hoping this was here. Rafaela, can you read the question?
What if strapped C4 to a boomerang. Could this be an effective weapon, or would it be as stupid as it sounds? I don't know what's a C4.
It's a
Does
bomb.
anybody know? Yeah, C4 is a bomb. Weapon. Can you
Okay.
repeat weapon?
Weapon?
Hmm.
Weapon?
And does anybody have any other questions here? Okay. And Misael, can you read the last paragraph?
Aerodynamics aside, I'm curious what tactical advantage. Sorry. What tactical advantage you would expecting to gain by having. Sorry, the
That's
high
okay. It's a
explosive
funny
fly back at you if you misses the target.
one. Good. So I'm curious what tactical advantage. Tactical advantage.
Tactical advantage.
Good. And I think this kind of speaks for itself. Does anybody have any questions on this last one? Okay. So hopefully you enjoyed class. It was fun. I enjoyed it. Nice to see you guys. Rafaela, nice to meet you. And have a really good night or day.
Thanks,
Okay, nice to
teacher.
meet
Take
you.
care.
Thank you, you too. Good night there.
I
Bye.
really like this